So assignment alcohols and halogen alkanes, the unit 2 topic. The doubts related to this, the first one is question 3 part F1 and 2 or 3 part F. Question 3. Methanol and ethanol are both GLVs, and there are a number of the fragments, fragment weak, which appear in a mass spectrum of both compounds. Somewhat surprisingly, OH is not one of them. Suggests the formula of and the mass to charge ratio of two fragments that would expect to occur in both spectra. Look, in a mass spectrum, what we do, we break down the molecule into fragments. So when we break down the molecule into fragment, we break from left to right, and then we can break from right to left. So if we have methanol, this is methanol CH3 and OH, and ethanol will be there CH3 CH2OH. So which one it will break down? If we break from left to right, so it might be CH3. So if it is CH3, it will be carbon is 12 plus hydrogen is 3. So like 3 hydrogen are there, so that will be 15. Or if hydrogen is removed only, because only 2 are there, if hydrogen is removed, then what it will be? It will be CH3O. So if CH3O is there, then already 15 plus 16, oxygen is 16, so 15 plus 16 will get at 31. That is when we break from left to right. If we break from right to left, it will be like if hydrogen is removed, we might get at H plus. Or we might get at OH, or we might get at CH3 OH plus. So this CH3OH, that's a molecular ion peak. So what will be the mass here? Carbon is 12 plus hydrogen 4 are there, so 16, 16 plus, so we'll get at 32. And this is 1. Now when we break this from left to right, so this will be CH3, so 15 will be there, or CH3, CH2, 24 plus 5, that is 29. Or we might get at CH3, CH2O. So this will be, when we break down CH3, CH2O, so 24 plus 5, 29, and 29 plus 16, so that will be 45. Now we break from the right hand side, so maybe we'll have proton H plus, or we might have CH2O like OH and CH2, or we might have the molecular ion peak, which is OH, CH2 and CH3. So this will be CH2OH, carbon is 12 plus hydrogen, 3 hydrogen, so 15, and plus oxygen. So 12 plus 3, 15 plus oxygen, so that will give us 31. So in the question, they're asking which two peaks we will get, which are common here. So like suggest the formula and mass to charge value of two fragment ions that would expect to occur in both. So first fragment, you can see CH3. CH3 can occur in both. They both have the mass 15, so it means we'll write CH3 here. The second fragment, which one is another one is having a common mass, that is CH3O or CH2OH, that both have 31. So we cannot distinguish which molecule is this, like because of which molecule. So we can write CH3O, or we can also say CH2OH. So these are the ions which can be common, like their mass to charge ratio might be common. And then give the formula of the fragment ion that would expect to be present in a mass spectrum of ethanol but absent in methanol. So which one is fragment present in ethanol but it is present in not present in methanol or absent in methanol? So you can see this one 45. The 45 is present in ethanol but it is not present in methanol. So we can just write here CH3CH2O, which is 45. It can be there in ethanol but it cannot be there in methanol. And even it is not possible to be in methanol, because if the total mass of the methanol, when we check, carbon is 12, hydrogen is total 4, so 16 plus, so the total mass is 32. So it cannot give a peak of 45, so it can never be there. Is it clear, this question? The fragment which are common and the fragment which are not common? Alcohol such as ethanol undergo number of reactions. That is question 9, C1 and C2. Okay. So in C1, what happened? The destination product ethanol is dried, and then it was tested. What test could you use to show that the sample is contaminated or contain ethanol or ethanoic acid? So we can add sodium metal can be added, or phosphorus pentachloride can be added, and it will give a misty fumes. Then physical method can also be used to identify the molecule. Give the formula of fragment that produce a peak of in the mass spectrum of ethanol but not in ethanol, and identify one feature in infrared spectrum that ethanol can be distinguished from ethanol. Look, if we have ethanol, we draw the structure, we draw the write the formula for ethanol. It will be CH3CHO, that is ethanol, and ethanol will be CH3CH2OH. So what will be the fragments? First we break from left to right. So it is CH3. We'll get a peak at 15. Or it might be CH3CH2. CH3CHO. That is a molecular ion peak. So carbon is 12 multiplied by 2. So it will be 24. Plus 4 hydrogen are there, 28. And plus oxygen is 16. So that makes 44. So the total will be 44 for this one. Or if this hydrogen is removed, so this is a molecular ion peak, and if this hydrogen is removed, so CH3CO will be there, where we'll get this peak, because so this will get at 43. So breaking from right to left or left to right, it will be same here, because either we'll get CHO. So if we get this CHO, carbon is 12 plus hydrogen, uh, 12 plus 16, 28. So we will get a peak at 29. And then we will get the whole molecule, which is 44. Now for ethanol, when we break down this ethanol, it might be CH3. So left to right 15 will be there. CH3, CH2. So 24 plus 5, so 29 will be there. So 29, and then the molecular ion will be there, CH3, CH2OH. So 24 plus 6, 30, 30. So plus 6, 16. That will be 46. Molecular ion peak will be there. And when we break from right to left, it will be CH2OH. So 12 and plus 16, 28 plus 3, 31. So there will be peak at 31 as well. Then we can have a molecular, the whole molecular ion will be there. That is at 46. Now in the question they're asking, give a formula of a fragment that produce a peak in a mass spectrum of ethanol but not in ethanol. So that is not present in ethanol, should be there in ethanol. So which one? This is a molecular ion. Molecular ion, definitely molecular ion peak will be different, but we are not supposed to write molecular ion. We have to write a fragment, part of it. So I cannot write a molecular. So I'm left with CH3. I'm left with CH3CO. So CH3 is already there. So but CH3CO is 43, and we don't find any peak of 43 in ethanol. So that's why the mass spectrum, the peak which will be there in ethanol but not in ethanol, that is CH3CO. And you should don't forget to write the charge, because they're asking for fragment. In a mass spectrum, only ions can be detected. So whenever you're writing a fragment, you should write a plus charge as we remove the electron out from it. Then the second part is in terms of IR. So better when you are explaining the idea of IR, better draw the structure, shows the bond, so you can distinguish that the type of the bonds which are present in one molecule and absent in the other. So you can clearly see the carbonyl group C double bonded with O group is present in ethanol, but it is not present in ethanol. And we have to identify one feature in infrared of ethanol that distinguish it from ethanol. So ethanol contain a carbonyl C double bonded with O, but in ethanol it does not have this group. Is it clear? Then the next question is question 14A3. This question is about two halogen. One is a primary halogen, another one is a tertiary. Draw a skeletal formula, then naming is there. The doubt was question 14A3. Then write an equation for a reaction of X with alcoholic solution of ammonia and name the product. So if X, whenever in alcoholic ammonia they are reacting, nucleophilic substitution reaction will occur, and it result in a formation of amine. So when we complete the equation for this, so this is X, it is reacting with ammonia. So ammonium is NH3. So in NH3, NH2 is partial negative and one of the hydrogen is partial positive. I'm first explaining the idea, then I will write the equation. This is partial negative and partial positive. So nucleophilic substitution is there. NH2 will take position of Br and Br will be removed. So if we have alcoholic ammonia, then in that case, we'll have a nucleophilic substitution reaction. But if we have like potassium hydroxide or sodium hydroxide alcoholic, that time elimination reaction will occur. So NH2 will take position. What will the product? It will be CH3, CH2, 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 NH2, amine will be there, like butylamine, or then as a result, what is produced? H and Br, because this hydrogen combined with Br. Okay. Then this HBr, this hydrogen bromide, because this reaction occur in excess of ammonia, like we should have excess of ammonia, otherwise multiple substitution might occur. So that HBr which is produced here, that also reacted with ammonia, because HBr is acidic, it reacted with NH3. So as a result, it will produce ammonium bromide. So we can write, instead of writing HBr, we write ammonium bromide, because we have excess of ammonia, like we have more ammonia. As a result, it will produce an ammonium bromide. So why HBr is not as a product? It is produced first, but that HBr reacted with another ammonia, and as a result, it will produce ammonium bromide. So that's why the final product should be ammonium bromide plus butyl amine. And name of this is amine, and 4 carbon are there, butyl. So that's why we call that as butyl amine. Is it clear, this question? So we always consider that we have excess of ammonia, like we have more ammonia, until unless they mention in the question that we have a limited ammonia. If there's a limited ammonia, then multiple substitution will occur, and until all of the hydrogen attached with the nitrogen are replaced by alkyl groups. Then question 17. In this question, we have to name the skeletal formula is given. So this is a branch, so chlorine is attached as a branch. We count the carbon atoms: 1, 2, 3, 4. So second position, there's a chlorine attached, so we say 2 chloro. And because 4 carbon atoms are there, so it is but, and they have single bond in. So it is 2 chlorobutane. So the systematic name is 2-chlorobutane, or A should be the right answer. Why we did not count from other side? Because if I count from other side, 1, 2, third position will be chlorine. So we always count the carbon where it is closer to the functional group. That's why we counted the first carbon at the top one. So 1, 2, 3, 4. This is not a carbon. This is basically chlorine is attached as a branch. This is not the carbon. So that's why it is 1 chloro or 2 chlorobutane. Is it clear, discussion? Next is question 19b2. Look, halogen alkanes are important intermediates in organic chemistry. Like using the halogen alkane, we can produce many of the products. So identify the reagent for A. Basically, it's a elimination reaction, halogen alkane. This is an elimination reaction. This is a nucleophilic substitution reaction, SN reaction. And alcohol, it's from alcohol, so that is also nucleophilic substitution, and alcohol react form halogen alkane, that is by reacting with either PCl5 or hydrogen bromide. Identify the reagent and any specific condition for these reactions. So the first one, because we want elimination reaction as a result of an elimination reaction, like for to undergo elimination reaction, we prefer that we should have alcoholic solution and reacting with potassium oxide. The second one, nucleophilic substitution SN reaction is there. So it should be ammonia, and in a dry ether it is done, or alcoholic as well. The medium is alcoholic. For B, sorry, that's B. I was talking. So this one substitution. So this is not alcoholic. B, I was talking about D, not B. So for B, because we want to produce alcohol. So if we want to produce alcohol uh, from halogen alkane, so this should be in aqueous medium. And the last for C, by like converting alcohol into halogen alkane, so we should use like sodium bromide or a mixture of sulfuric acid and sodium bromide, so it will produce hydrogen bromide, and that can further undergo substitution reaction. And the last one, alcoholic ammonia. The second part, classify the type of reaction A. So A is elimination reaction, as I mentioned in the beginning, and D is nucleophilic substitution reaction. So halogen alkane undergo nucleophilic substitution reaction and elimination reaction. Is it clear? Part 19B1, that, and the second one is B2, that's the doubt. Now reaction B can proceed via two possible reaction mechanism depending on the structure of original product, original compound. For each of the isomers C4H9Br shown below, draw the structure of intermediate or a transition state. Look, it's a primary halogen alkane. If it's a like carbon is attached to a halogen which is surrounded by one carbon chain, so it is a primary. And primary, the bond breaking and bond forming will take place at the same time. And the second one is a, which is given here below, is a tertiary. So first the bond will break and then the bond will form. So when we draw the intermediate here, like 1, 2, 3, so 3, I can just make it short, like this is C, this is a carbon C, hydrogen, one hydrogen down, and this one, two, three carbon are there, so C3 and H7, and then Br. So the intermediate bond breaking, the OH will try to form a bond, and Br will try to break the bond. Bond forming and bond breaking and bond forming will take place at the same time, and the intermediate will have a negative charge on it. So OH, as it is trying to form a bond, as it is a primary halogen alkane, OH will attack on the carbon, partial positive. The bond breaking and the bond forming will take place at the same time. Explanation you will mention, it's a primary halogen alkane, so attacking nucleophile find a space to attack on the carbon, partial positive carbon. That's why the bond breaking and bond forming is taking place at the same time. But what about the tertiary? Tertiary, the attacking nucleophile does not find any space because it is surrounded by alkyl groups. So this we call steric hindrance. So due to steric hindrance, the attacking nucleophile does not find a space to attack on this. So first the carbon will break the bond with bromine, so it will form a carbon cation, and the carbon cation here, which is surrounded by alkyl group, is more stable. That's why here the carbon cation is surrounded by three alkyl groups, so it will be more stable and the intermediate will have a positive charge. And due to this intermediate positive charge, then attacking nucleophile now can find a space and attack on this carbon. But why it does not happen for the primary? Because if it happened for a primary, like it break the bond with bromine, then this will be partial, this will be positive, but you can see this is only surrounded by one alkyl chain, rest two are hydrogen, so it is less stable. So you can also mention in an explanation, you can mention why intermediate does not form a carbon cation here, because that carbon cation won't be stable as it is surrounded by few alkyl groups. Where in tertiary, the carbon cation is surrounded by more alkyl groups. That's why it is more stable. Or you can also mention due to the steric hindrance, the attacking nucleophile does not find space to attack on the carbon. That's why first the bond will break and then the bond will form. Is it clear? The difference between the two mechanisms? Next question is 26A and C. Some organic molecules either on their own or as a part of a mixture contribute to some unpleasant odor. So the molecule is shown, isovaleric acid is there. Which part is a doubt? Question 26, A and C. What is the systematic name? We have to work out the systematic name for isovaleric acid. So isovaleric acid, this is isovaleric acid, systematic name. So this is 1, 2, 3, 4. Third position, we have a methyl group. So it is 3 methyl. And 1, 2, 3, 4. 1, 2, 3, 4 are there. So it is bute. They have a single bond N. And because of this functional group, it will be oic acid. So it is 3 methyl butanoic acid. Then the next part, isovaleric acid has three structural formula which are also carboxylic acid. One of these acid is drawn in the box. We have to draw in the empty space, draw the skeletal formula of the other two carbon and structural isomers. So structural isomer means we can just change the structure. Look, this won't change. This part won't change. That will remain as it is. So the only thing which can change, we can make a branches. So C double bonded with O and OH is already there. So this is one carbon, like one carbon, then two. This is a second carbon, then a third carbon. This is a third carbon, and then I make a branch. Or the next one, C double bonded with O is already there. C double bonded with O and OH is already there. We cannot change that. So one, this is one, two. So I do second one, and then one branch up, one branch down. So that is another structural formula. So we have to draw the skeletal formula of two different structural isomers of this compound. Is it clear? B4. Okay. 22 before. This was question 26. State how the polarities of a carbon halogen bond vary and why the polarity does not determine the rate of the reaction. Look, which bonds are polar? Carbon chlorine bonds are more polar than carbon bromine bond, and carbon bromine bonds are more polar than carbon and iodine bond. Polarity, like, because what happened when electron, like the two non-metal, they share electron between them. So due to the difference in the electronegativity, as they have a difference in the electronegativity, the electron pair is shifted towards the side or the atom which is more electronegative. So we know chlorine is more electronegative than bromine, and bromine is more electronegative than iodine. That's why the electron pair distributed or shifted more towards chlorine rather than bromine, and bromine rather than iodine. And then the rate of the reaction, like which one react faster, this one will react faster than the other one, because the rate of the reaction depends on the bond energy. Because carbon and iodine, longer bond is there, so smaller, like weaker attraction, like greater distance between the nucleus of two atoms, so weaker attraction between the shared electron. That's why this bond can break easily. So rate of the reaction depends on the bond energy, and bond energy of carbon iodine is lower as compared to carbon chlorine. Why? Because it's a longer bond. As it is a longer bond, it means weaker attraction between the two at the nucleus of the two atoms to the shared pair, so it can break easily. Whereas carbon and chlorine bond, because atoms are closer to each other, so bond is stronger. So speed of the reaction not depends on the polarity. Speed of the reaction depends on the bond length as well as the bond energy. So you can compare, like carbon iodine is having a longer, it's a longer bond, so means less energy is needed, or weaker bond, so less energy is needed and it can break easily. So this was question 22. Then 27 and 29. So in question 27, the skeletal formula of 5 carbon atoms, halogen alkane, which of the above is not a structural isomer? So you have to count, because to know the structural isomer, they should have same molecular formula but different structures. So when you count the number of the carbon atoms, here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, and 5. Then the second thing what you will check to be an structural isomer, the type. This appear to be cyclic. This also, there's a ring cyclic. This also cyclic, but this is a straight chain. So it means what is not common, that D is not a structural isomer, because D is having like a straight carbon chain where others also contain a ring. That's why D is the right answer. Then which of the above is not a secondary? Secondary, the carbon should attach to a halogen should be surrounded by two carbon chains. So when we check A, this carbon is surrounded by two, that's right. When we check B, so 1, 2, and 3 are there. So this is not a secondary, this is a tertiary. That's why B is the right answer. Is it clear? Then question 29 and 32. So 29, the molecule is shown 3-chloro-3-methyl-hexane. It reacts with alcoholic potassium hydroxide to produce number of alkenes. Which of the following could be produced from 3-chloro-3-methyl-hexane? So what will happen? The Cl will be removed and one of the hydrogen will be removed. So if this Cl is removed, there will be a double bond either on the right hand side. The double bond will form elimination. This is alcoholic. Yeah, elimination reaction will occur. As a result of this elimination reaction, so this Cl won't be there. So there will be a double bond either with a on this side or the other one. I'll share another link and continue this discussion. Less than a minute left, so I'll explain this question.